from Mr. Fregoso.
We have deep conversations about life.
That's very good to hear.
Did I get another 5.4?
Yeah, I think so. Yep, there you go. Yep. Okay. All right. Listen up. Thank you. Okay. Let's see. So today's Thursday. We're going to finish up 5.4. Tomorrow we're going to review. Hopefully you've downloaded the review. And then when is the test on this stuff? Test is on Monday. Okay. All right. So on the first page, we had all of these theorems. I think we had 4 theorems and then a corollary. Okay. And we went through and did a couple problems. This one could have been in 5.2. This one wasn't too bad. We ended up with 3 real zeros. And then we did this one right here. Again, a third degree polynomial, so we're looking for 3 zeros. It says find all the zeros. So whether they're real or imaginary or complex, doesn't matter. We want to find every one of them. So we found 1, 2, 3. Found those. Then we talked about if we've got a 5th degree polynomial and I've got this as a 0, this is a 0, and this is a 0, what are the other 2? And for that we used, how did we know this one was a 0? If 1 plus I is a 0, how did we know 1 minus I is also a 0? Shane? Okay, the imaginary zeros always come in pairs. They're called conjugate pairs. Okay? So we used that, and then we used that same thing and the fact that we could make a factor for each one of those and then multiply them all together to make a polynomial. Luckily, you only have 1 or 2 problems that ask you to do that because it's pretty easy to come up with the factors, but then you've got to multiply those together in order to produce the polynomial. That can be a little bit of a pain in the butt. We did go over this, though. There are a lot of patterns using perfect squares and difference of squares and stuff like that. If you have a choice, multiply the ones that have i's in them that are conjugates of one another together first. That'll make life a little bit easier. Okay? And then we did this problem right here. It was a 4th degree polynomial, so we had to find all 4. And when we found all 4, we had 2 real ones and 2 imaginary ones. And these were nice rational ones. They came from our list right there. Okay? Any questions? Raise your hand if you got started on the assignment from 5.4. All right, not too bad. Okay, a little over half. That's pretty good. Okay, let's take a look at number 3. This is similar to one on your assignment, or it might even be on your assignment. It says, use the information to find the remaining zeros. It says we've got a degree 4 polynomial, so how many zeros do there have to be? Got to be 4. They gave us I, and they gave us 1 plus I. If I is a 0, what else is a 0? Negative I. If 1 plus I is a 0, what else is? 1 minus I. It's that simple. Okay? Piece of cake. Then on number 9, it says we have a degree 6 polynomial. How many zeros will there be?
6.
There will be 6 complex zeros. Now, they may not all be real zeros. They may not all be rational zeros, but there will be 6 complex zeros. So, let's see. 2. Does that help us at all? Other than the fact that that's one of them. They just told us one of them. Okay, 2 plus I? 2 minus I has got to be also, so we're up to 3 so far. Negative 3 minus I? So that'd be negative 3 plus I. Again, always coming in conjugates. And then the last one is 0. Okay? So there are all 6 of them. And we could write down the factors that come from each one of those, or that correspond. Okay, so some of the problems are that easy. And then let's take a look at problem number 11. It says, form a polynomial with real coefficients having the given degree and zeros. So let's take a look at this one right here. This is similar to the one that we just looked at on the other page. I am going to go through and do this one completely. We'll get the entire answer. It's a degree 4 polynomial with that as a 0 and that as a 0 with multiplicity 2. So if 3 plus 2i is a 0, what else is a 0? Okay, so I've got 3 minus 2i, I've got 3 plus 2i, and I've got 4 with a multiplicity of 2. Okay, what's the factor that corresponds to this one? Don't say anything, just write it down. Because you're going to have to do this on the test and you're going to have to do this on the assignment. What factor would that correspond to? Hold on. it's going to be x minus all of that stuff. So it's going to be x minus 3, and then minus a minus 2i is going to be a plus 2i. Write down the next one. It's going to be x minus all of this stuff, so it's going to be x minus a 3, and minus a positive 2i is going to be minus a 2i. And then when we did this the other day, I pointed out, you can look at this, if you even read this, it sounds like a conjugate. It sounds like a difference of squares. X minus 3 plus 2i, and x minus 3 minus 2i. Okay? See how the I part, that's the one that changes signs? Okay? And then what if we've got 4 with the multiplicity of 2? The factor that comes from it would be x minus 4, quantity squared, or we could write another x minus 4 if you want. Everybody good there? Okay. I went through kind of a shortcut to do these. So for this one, it's going to be a perfect trinomial square, so that's going to be x squared minus 8x plus 16. Everybody good there? Okay, what was the hint here? Okay, you think of it as x minus 3 plus 2 and x minus 3 minus 2. You think of it as a difference of squares. So this is going to be x minus 3 quantity squared minus 2i quantity squared. That's what we're going to get. So this is going to be x squared minus 6x plus 9, and then I'm going to have minus 4i squared. Let's see. 4i squared minus 4i squared. What does minus 4i squared count as? Positive 4. That counts as a positive 4. So I'm going to cross that off, count that as a positive 4, and then I'm going to write down what we've got. I've got an x squared minus a 6x. That's going to be a plus 13. Is everybody okay with that? And this one is x squared minus 8x plus 16. Now, I wouldn't put one of these on the test for 2 reasons. One, the numbers, even if we have fairly small zeros, these numbers get fairly large pretty quickly. And this kind of takes a lot of time to do. Okay, I'm not really interested in whether or not you can multiply these together, but this is a good exercise to do just a couple of these. So we'll do one here. I think this one's on your assignment. Okay. So now we just need to multiply these together. So there are 3 terms here and 3 terms here. Every one of these is going to get multiplied by every one of these. So how many terms will I have altogether to collect? 3 here times 3 here. I'm going to have 9. So I'm going to do x squared times each one of these. So that's going to give me x squared minus 8x cubed plus 16x squared. Did I do that okay? Oh, to the 4th. Yeah, thank you. Thank you. Okay, then I'm going to do I'll change colors here. I'm going to do the negative 6 times each one of these, or the negative 6x times each one of these. Okay, if I do that, I get minus 6x cubed. I get plus 48x squared. And then, let's see, negative times a positive is a negative, and I have 6 times 16. That's going to be 96x. And then the last one, I'm going to do 13 times each one of these. So you might want to grab a calculator for this. First one's pretty easy. That's going to be 13x squared. Then I'm going to have minus 8 times positive 13. That's going to be a negative. And let's see, 13 times 8 is 104. Double check me on that. 104, and that's going to have a plain old x on it. And then I'm going to have a positive times a positive, so this is going to be plus. And then I've got 13 times 16, 208. Okay. Oops, 208. There. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are the 9 terms that we need to collect. So I'm going to change colors here. Okay, I'm going to go through and I'm going to collect like terms. There's only one x to the 4th, so I'm done with that one. Then let's look through and grab the x to the 3rds. There's one here and one here. No other x to the 3rd, so that's going to be minus 14x to the 3rd, and I'll cross that off since I'm done with it. Let's go through and gather up the x squareds. Here's 16 of them, 48 of them. That would be 64x squareds, and then there's one more. It's a plus 13. So 64 plus 13 is going to be 77x squared. Cross off the x squareds. Notice how I cross them off kind of lightly so you can still see what it was to begin with. If you scribble it out, you lose some of your work, and then if you make a mistake, it's tough to go back and find what you did. Then I've got a minus 96x and a minus 104x. Well, those are pretty good because what do those add up to? 200x, negative 200x, and then the number on the end is 208. So there we go. Okay, there's our fourth degree polynomial that would have two complex zeros of 3 plus 2i and 3 minus 2i, and then a double zero, okay, or a multiplicity 2 0 of 4. Okay? Lots of fun, right? Good. Okay, let's get back to the good stuff. Ready?
Yes.
Okay, if you'll notice, problem 3, piece of cake. Problem 9, piece of cake. Problem 11, not that hard, just a pain in the butt, right? Okay, take a look at number 17. I think this is a little easier than number 11, but you've got to use your head. And remember, we talked about that's what's important about these. It's not that anybody's going to ask you to do these in the future unless you're taking a math class. Okay, it's the fact that you can take little bits of information, little details, and fit them into the big picture and then use those to help you figure out a problem. So this one says, use the given zeros to find the remaining zeros of the function. What degree is this? 3. So we need 3 zeros. How many did they give us?
2.
Okay, well, I heard some people say 1 and some people say 2. Which is it? Yeah, it's really both, right? So they gave us 1, but you can immediately find another. If they tell us one of them is 2i, then one has to be negative 2i. Okay? So I have 2 zeros. Now, normally when we have a 0, we go through and we do synthetic division. And we find a depressed polynomial, and then we factor the answer, maybe use the quadratic formula, or maybe use the P and Q stuff again, or something like that. Okay? Oddly enough, you could go through and do synthetic division with i's in it. It is possible. It's very difficult, and you have to be really, really organized to do it. But we could divide by 2i, and then divide by negative 2i, and then we'd have one factor left, and that would tell us what the 0 is. Okay, but that's kind of a pain in the butt. It would be much better if you did this. If you said, look, 2i is a 0, and negative 2i is a 0, so what factor comes from this? X minus 2i and x plus 2i, right? Well, we could multiply the two of those together and make a factor. That's going to be x squared minus, this would be 2i squared. Difference of squares. So that's going to be x squared. What would, well, let's see, that would be minus 4i squared. What would that count as? Plus 4. Okay, if those two are factors, that's got to be a factor also, because we just multiplied them together. Okay, it's like saying this. Everybody watching? Okay, is 2 a factor of 20? Is 5 a factor of 20? Yes. If I multiply those together, I get 10. Is 10 a factor of 20? Yeah. So x squared plus 4 is also a factor of this right here. So rather than divide by this one, then this one, let's divide by both of them at the same time. Let's take x squared plus 4, and let's divide it into x cubed minus 4x squared minus 4x minus 16. Does that make sense? Okay, instead of taking 20 and dividing by 2 and seeing what's left, instead of taking and then dividing by 5 and seeing what's left, let's just take 20 and divide it by 10. That's the equivalent of what we're doing here. So, what do I multiply x squared by to make it an x cubed? Multiply by an x. By the way, why am I not doing synthetic division? You can't do it with an x squared. Very good. Okay? So I multiply here, I get an x cubed, And I get, now careful here, this is a 4x. Where do I put it? Right here. That's where I put it. Then I subtract. So this is going to be a minus 4x squared. This is going to be a minus 8x. And what? Oh. Oh, I see. That's a plus. There we go. That's better. I was starting to get worried. Okay, so those make a 0, and then this is a minus 16. Thank you for finding that for me. Okay, everybody good there? Okay, what do I multiply x squared by to make it a negative 4x squared? Just a negative 4. So I'm going to have a negative 4x squared, and when I multiply these together, I get a negative 16, and then I run through and I subtract, or in other words, I just change the signs. So those would be plus. So what's the remainder? The remainder is 0. Okay? What does that mean about this? Okay, well, what it means is this is a factor, and it means it goes in evenly. This is our quotient. That means this also is a factor. So if we had to write all of them down, there's x minus 2i, there's x plus 2i, and then there's x minus 4. So just to double check, okay, you don't have to do this every single time. I kind of just do it out of habit. The 0 that comes from here is 2i. We already knew that. The 0 that comes from here is negative 2i. We already knew that. What's the last one? 4. 4 is the last one. Okay? So not too bad, right? Just use your head and then do some long division. Any questions? Okay. All right, flip the page over. Let's see. 2 problems on this side. Okay. I can absolutely guarantee that there will be a problem on the test like these on Monday. Okay, so you have to know how to do these. The nice thing is, the only difference between these problems and the one we did in 5.2 is that this says find the complex zeros. If it says find the complex zeros, you have to find all the answers that have just plain old regular numbers or have i's in them. So if it says find the complex zeros, that means find them all. So on this one, how many are we looking for? 4. We have to find all 4. Okay, now, take a good look at that. Anybody have any ideas where to start? We can always start with P and Q, okay? That's going to give us the nice ones first. That'll work. So the cool thing about this is P is 1 and Q is 1. So our list is plus or minus 1. Those are the only possible rational zeros. Okay, so let's see. Does 1 work? Yeah, 1 does work. Okay, so let's put a 1 in the box, and then let's put, now be careful with this, 1, 0, 0, 0, and a 1, right? Oh, negative 1, thank you. Good? Bring down, multiply, add, multiply, add, multiply, add, multiply, add. What does that mean about this? It is a 0, which means it corresponds to a factor of x minus 1. And what is this stuff? X cubed plus x squared plus x plus 1. Okay, now, what name do we give this again? Okay, even though it's depressed, why do we like it? It's easier to work with because it's a lower degree. Okay, now everybody listen please, because this one's not going to be too bad. We're going to think about this for a second. This one's going to work out very easily. Okay, the depressed polynomial is easier to work with. You can factor it if it factors. Okay, or you could do the P and Q stuff again. So P on this one would be 1, Q would be 1. We'd get the same list. We could try 1 and negative 1 and see which one works. Okay? So if you have to use P and Q, go ahead. But when you get to a point where you can factor, try factoring. This has 4 terms. We know how to factor 4 terms. Okay, or at least we can try to factor 4 terms. We can group these. Will that work on this one? Could I group the two of these together and the two of these together? Well, let's check and see. What can I take out of the first one? What's left? X plus 1. What can I take out of these two? Please say it right.
Plus 1.
There we go. Positive 1. I'm left with an x plus 1. Now, do I have something in common here? Yep. I've got an x plus 1. I'm left with an x squared plus 1. Okay. Don't forget this guy. So I've gone from working with a degree 4 polynomial. I've got a linear factor here, which I can see what the 0 is. I know what the 0 is that comes from that one. I've got a linear factor here. I can see what the 0 is that comes from that one. And what do I have right here? What do we call this again, Alex? Irreducible. It's called an irreducible quadratic. Okay, that will not factor, so what do we use to solve that? Quadratic formula, or you could set it equal to 0. Okay, which is easier in this particular case? Let's set it equal to 0. So we're going to take x squared plus 1, set it equal to 0. That's x squared equals negative 1. So when I take a square root, I get plus or minus I. Okay? So the zeros are 1, negative 1, negative I, and positive I, right? There are all 4 of them. Okay, so I found all the complex zeros. We knew we were looking for 4. It says write it in factored form. So I'd want to write x minus 1, x plus 1, x plus I, and x minus I. See how this fits with what we've been doing all the way along? Here are the zeros, and here are the factors. Okay? Any questions? Sure? Okay, watch. You don't need to write this down unless you want to. Is everybody ready? Done writing that stuff down? Okay. Whoops. How many terms are there in this polynomial? 2. Only 2 terms. Do we have rules that will help us factor 2 terms? Yep. Difference of squares, difference of cubes, or sum of cubes. Now that's not a sum, so it's either got to be a difference of squares or a difference of cubes. There's no way that's a cube. So we're down to difference of squares. Could we write x to the 4th as a perfect square? Sure. X squared squared, right? Is 1 a perfect square? So this factors to x squared minus 1 and x squared plus 1. This is a difference of squares, so it factors to x minus 1 and x plus 1. Okay? And 1 is a perfect square of I. So this factors to x minus I and x plus I. And what's the 0 that comes from here? 1, negative 1, I, and negative I. Okay. Could you do it that way?
Yeah.
You could. Is a problem like that going to be on the test where you don't have to use any of the P and Q stuff and things like that? No. No. Okay. The one on the test would be more like this one. Okay, so can I move on? Okay, all right. Okay, would you go ahead and try that one, please? Go ahead and get started on it. The instructions are find the complex zeros, which means find all of them. So all 4 of them. Okay, go ahead. And same instructions as above. So find the zeros and write it in factored form. Caitlin doesn't have a calculator, so we're going to help her out here. Does it have anything in common? Can we take anything out of all of them? Yeah, there's not a 3 there. It'd be cool if we could. Stupid thing has 5 terms and we can't even take anything out. What do we do? P and Q. Okay? So P on this one is 52. Q is 3. Holy cow. So 1, 2. Does 3 go in there? Nope. 4? Yep. 5? 6? Nope. 7? Nope. 8? 9? 10? Okay, let's write down the ones that this goes in with. So this would be paired with 52. 2 would go with 26, and 4 would go with 13. Okay? Nothing else. Okay? So at least there are only 6 there. For Q, 1 and 3. Okay? I gave you a little shortcut yesterday. If you take every one of these and put them over 1, you're just going to rewrite those numbers. So let's keep these right here, and then let's add 1 over 3, 2 over 3, 4 over 3, 13 over 3, 26 over 3, and do we need 52 over 3? Okay. 52 divided by 3. Is it going evenly? Nope. Holy cow. Plus or minus in front of every one of those. And that's just the possible nice ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 24 possible rational zeros. Is there any way they're all going to work?
No.
And gosh, I hope one of the first couple work that are nice numbers. Okay? Let's hope that's the case. Okay, what do you want to check first? Let's check 1. Now, if we plug in a 1, let's take a good look. 1's pretty easy because this is just going to be a 3. That's going to be a minus 10. That's going to be a 159 and a minus 52. Emily's our resident expert on this. Does 1 work? It doesn't work. Because look how big this positive is. There are only a couple negatives to balance that out, so 1 is not going to work. Okay? Negative 1 is only going to be slightly better. It's going to give us a 3. It's going to give us a 1. It's going to give us a minus 9. Is there any way this is going to work? So that's going to be a negative 159 and then a minus 52. Is there any way negative 1's going to work? Nope. Okay, now, once you've checked negative 1 and positive 1, those are pretty easy to do just by plugging in the numbers. May or may not be worth doing synthetic division. Once you get past 1 and negative 1, you're going to use synthetic division. Okay? We good there? Okay, so what are we going to try next? Let's try 2. So we're going to put 2 in the box. Make sure all of the numbers, all of the powers and everything are represented. So this is going to be a 3, a negative 1, a minus 9, a 159, and a negative 52. Bring down, multiply, add. So that's going to be a 5. Multiply, that's going to be a 10. Add, that's going to be a 1. Multiply, so that's going to be a, what do we got here, a 2. So that's a, holy cow, is this going to be anywhere close? No, so we can stop right there. Okay? So if you write lightly, you can just go back and erase, like I just did. What are we going to check next? We're going to check negative 2. So we're going to put a negative 2 there. So this is going to be 3, negative 6, negative 7. Put these together. That's going to be a negative 14. Oh, positive. Yep, positive. So this is going to be a 5. Multiply here. Let's see. So that's going to be a negative 10. So that's going to be a negative 149. Is that going to work? Nope. I believe in the textbook they go over a way where you can just like cross this out and slide the numbers down or something like that. So you just cross these two out, put another line, and then just bring them down further if you don't want to erase. But again, I like just writing lightly. Okay, plus and minus 1, plus and minus 2 are out. Yeah. We should try 1/3. Why do you think? Okay. John thinks 1/3 is going to work. We could go through that entire list. Let's try 1/3. Okay, now we've done synthetic division with fractions before, and usually it looks like it's really awful, but let's check and see what we get here. So this is going to be a 3. 1/3 of that is 1. We're going to add those together and we're going to get a 0. That's a 0. That's a negative 9. Well, this is good because 1/3 of negative 9 is negative 3. So this is going to be 156. And then we're going to multiply by 1/3, and that's going to be 52. So we end up with 0. So what happens here? That's our 0. Okay? So what is this that's left? This is our depressed polynomial. Okay? So this is going to be x to the 3rd. Okay? No x squared, so I'll just write minus 9x plus 156. Good? Okay. How many more do we need to find? 3 of them. It would be really nice if this factors. Does it factor? It doesn't factor. Okay? We can take out a 3. Okay? Now, why is it nice to take out a 3? Much smaller numbers, and here's the cool part. Okay, once I take out a 3, now remember, this corresponds to a factor of x minus 1/3. Okay? And there's what I've got here. So if I take out the 3, here's what I've got. That's an x cubed. That's a minus 3x. And that's a 52. Okay, now here's the great part. This doesn't factor, but what is the p on this one and what is the q on this one? 1 and 52. So that means the only possible rational zeros from this have to come from that list of 1 and 2 and 4 and 13 and 26 and 52. Okay? Now, John gave us one of the answers. It was 1/3. But if there are any nice answers to what's left, they've got to come from this list. Okay? Of course, we need the pluses and minuses in front of them. Didn't we already check 1 and negative 1, 2 and negative 2? So if they didn't work in the original one, is there any way they're going to work in this piece right here? Nope, so we can cross those off. So should we try 4? Let's try 4. So we're going to do 4 in the box, and then I'm going to write a 1. I'm going to skip the x squared. Then I'm going to write a minus 3, and we're going to write a 52. Oops. So there's a 1. There's a 4. That's a 16. So that's a 13. Multiply, and we get 52. Close. It would be great if that were negative. I didn't make a sign error anywhere, did I? So hopefully we're okay. So let's try negative 4. That'd be negative 4. That's going to be a negative 4. That's going to be a 16, right? This is going to be a 13. What's this going to be? Negative 52. What does that mean about this? Negative 4 is a 0. So that means it corresponds to a factor of x plus 4. And what is this mess right here? depressed polynomial. It's x squared minus 4x plus 13. Okay, am I leaving anything off for the time being? I left these guys right here. Okay, let's bring those back just so we don't lose track of them. So I've got a 3 and I've got an x minus 1/3 here. Okay? This is easy to find the 0. That's easy to find the 0. What do we need to do with this? This is our depressed polynomial now. It's a quadratic. We can try and factor it. Are there any numbers that multiply to be 13 that combine to be -4? There aren't. Okay? So we're going to use the quadratic formula. So that's going to be x equals 4 plus or minus. That's going to be 16 minus 4 times a times c. So that's a 1 and a 13 all over 2. So that's going to be 16. That is going to be a minus, and we know what 4 times 13 is by now, 52. This looks awful, but it's actually good news. This is x equals 4 plus or minus. What goes underneath the radical? -36. Why is that nice? Okay, so this is going to be 4 plus or minus 6i all over 2. Well, everything's got a 2 in it, so this is going to be a 2 plus or minus 3i. So one of them is 2 plus 3i, the other one is 2 minus 3i. What were the other zeros? Positive 1/3 and -4. There are all 4 of the zeros. Okay, let's finish writing this in factored form. So this is going to be, let's see, this would be x minus 2 minus 3i, x minus 2 plus 3i. This one is x plus 4. Everybody watch, please. Look how nice this would be if I distributed through. This would be a 3x minus 1. There it is. There are the factors. And here are the zeros. Okay? Okay, you want the good news or the bad news? Okay, the bad news is you have some problems on the assignment like that. The good news is I could give you one on the test like that, but I probably wouldn't make it, so that you take out a 1/3 first. You wouldn't have to go through this list and get to 1/3 before you find one that works. I think on this one, if we had done one more and used the 4 and the -4, I think what we end up with turns out to be something that we might be able to factor, okay, or at least pull something out. And make life a little bit easier that way. Okay? Any questions? Okay. They don't get any more difficult than that. That would be a good test question. The ones on the test will be maybe slightly easier. Just a little bit, but you ought to be able to do this. Okay, are there any questions? Okay, raise your hand again if you started 5.4 yesterday. Okay. All right. Those people can go. If you didn't start 5.4, you need to get started on 5.4 and then show me a couple problems and then I'll let you go. Tomorrow, it's just all review, so you'll have time to work on 5.4. It would be really good if you came with questions on 5.4 and questions from the review. If you haven't downloaded the review, get that downloaded.